All right, this question is very similar to the previous one, except here we have a single replacement reaction. It says study this chemical reaction, then write balanced half reactions describing the oxidation and reduction that would happen in this reaction. So, just like the previous problem on this playlist, the first thing I notice is we have iron here, and we're not given the oxidation state of iron or the charge on iron since it's an ionic compound. Well, we can just use its charge. So we need to figure that out. So to figure that out, we have iron plus 2 times minus 1 equals 0. So why is that? Well, it's iron plus 2 times the charge on iodine. Iodide is negatively charged. It's a 7A metal, or excuse me, a 7A nonmetal. So it's -1 in ionic compounds, and there are 2 of them, and the overall charge on this and every other ionic compound is 0. So we can use this formula. The same that we would use if we were trying to find the Roman numeral in the name of this compound. So it's iron minus 2 equals 0. Iron equals plus 2. So we could call this iron 2 iodide. Or we can use this to find the oxidation state, which for iron is plus 2. For iodide, the oxidation state is -1 on this side, and it's also in an ionic compound over here, so it's -1 on this side. So in this case, iodide doesn't change. We can ignore it. In an oxidation reduction reaction, we only care about what changes. If something stays as the same oxidation state or as a spectator ion, we basically do not need to consider it. So we're going to leave that out. Let's look at magnesium. Magnesium is atomic here, or elemental, I guess I should say, so its oxidation state is 0. In ionic compounds, magnesium's oxidation state is always plus 2, and here iron is elemental. So iron goes from plus 2 to 0, and magnesium goes from 0 to plus 2. Remember your mnemonic device, Leo the lion says grr. And what this means, again, is losing electrons is oxidation, gaining electrons is reduction. So if something goes from plus 2 to 0, it has gained electrons. This is reduction. In this case, something goes from 0 to plus 2, it has lost electrons. So this is oxidation. So it first wants our oxidation half reaction. And notice that unlike the previous example, we are given states of matter here, so we want to continue to include those. So we have magnesium solid forms magnesium 2+ aqueous. Well, if you go from magnesium to magnesium 2+, you have to lose 2 electrons. So we're going to put those in there, plus 2 electrons. Now let's look at the other half reaction. We have iron 2+ aqueous, Fe2+ aqueous, and it forms iron solid. Well, if you want to go from Fe2+ to Fe, you need to add 2 electrons. So this gives us the oxidation and the reduction half reactions for this single replacement reaction.